Hi, thank you so much. I am really excited to be here, and so I appreciate being asked to talk a little bit about Python data visualization tools. Um, as I think a lot of developers and data scientists have experienced in their own practice, Python is not the top of line data visualization option. However, we find ourselves doing so much of the other work of data science and data science practice and machine learning in Python that this really makes for a challenging circumstance. You do all of the analysis, but you want to include visualization of data sets, of model output, of training statistics, of many other things in your data your data science pipeline. So I complained about data visualization in Python for years, probably. And one of the things that finally came down to was if I'm going to complain about it, I better figure out exactly like what the lay of the land is and sort of actually check to see, is there anything worth doing in data visualization in Python? And so I took a number of different data visualization libraries. I took 6 libraries and I produced 5 different kinds of visualization in each one and checked, tried to do as similar as possible in each one to really be able to see whether we're doing, like, whether there's something out there that's worth trying. So let's give it a try. This is my sort of ecosystem of libraries that I tested for this. And if you'd like to follow along here, you can certainly visit the GitHub link at the bottom of your screen, or just visit stephaniekirmer.com and the link in the events page to the materials for this. So we've got our old standbys, right? Matplotlib, developed in 2003. That might literally be older than some of you out there. And then it was rewritten pretty substantially in 2008, but it's still pretty old and tried and true, I suppose. But it is specifically, like, it's native Python, but it's trying to emulate a MATLAB syntax. And at my current, sort of perspective, I'm not sure why we would want to emulate MATLAB syntax today. If we were writing a new library today, like the 4 libraries on the right-hand side, we would not use this approach, I think. Seaborn then is developed in 2012, and that's sort of an add-on to the Matplotlib space, right? It's building on top of Matplotlib. One of the things about Matplotlib is that it doesn't give you any promises or guarantees about doing any work with pandas data objects. Matplotlib says you can use NumPy arrays, or data objects that are NumPy, but everything else, good luck, no guarantees. So Seaborn is trying to add proper pandas compatibility and like some more promises about how it's going to work. But it's really just a surface layer on top of Matplotlib. So Seaborn is not its own full-featured data visualization library. And even in the documentation that you see about Seaborn, for the official like writers of Seaborn, they'll say, to really get the full featured, sort of experience, you need to also know Matplotlib. I'm going to be opinionated here and disagree that you need either of those things, because I don't think that these are the best tools for data visualization in Python. And I think a lot of the bad reputation of Python for data visualization comes from the fact that these are the libraries that people often start with. So what are the new contenders in the game? Bokeh was actually developed in 2012 as well, so it's the same age as Seaborn. It is sponsored by NumFocus, so it has a pretty robust community of developers and support around it. And it does a number of particularly awesome things that we'll talk about in a few minutes. It adds interactivity, which is a big key. And so we'll go over some examples of Bokeh and show you how different it looks. Plotnine is developed in 2017. And it's a port of ggplot to R, from R to Python. So this we'll also talk about a little bit later. It has a very interesting backend that actually falls on top of Matplotlib. Altair, developed 2016, and it is based on Vega Lite, so it's a JavaScript-based backend. And Plotly is developed in 2013 for Python. It was already developed in 2012 for JavaScript. And it's not really Python specific. It's a port of JavaScript into Python. And so we'll talk about that a little later, in particular in relation to 3D visualizations. But so, okay, these are our contenders. What are my sort of criteria for evaluating whether a library is gonna be, you know, sufficient for what we're doing here? I have a few sort of standards that I'm setting. These may not be the same way that you would choose to evaluate a data visualization library, and that's okay. This is my opinion, and you are totally at liberty to take a different track with the way that you evaluate these things. I hope that the information that I'm giving you today will help you to make that evaluation regardless. So, easy learning curve. If you can't get started, then the rest of it's really not going to go anywhere. And that's a problem because you don't want to have a really great, really robust, full-featured library that no one can get started using. A power user can probably do kind of anything in these areas. A power user who really spends the time to learn the thing can probably make pretty amazing stuff happen. But we're talking about a busy person. We're talking about someone who doesn't have time to spend hours or days or weeks to learn the library in order to get where they're going. Grammar consistency, I think, is highly underrated. I think that just like when you're learning a foreign spoken or written language, being able to learn some basics and then improvise on top of that makes a huge difference. I think this is really important for a high quality library. So when you have one particular, you know, method of applying a title to a plot, if it works for scatter plot, it should work for a bar plot. In Seaborn, it does not. So I think that this makes a difference. And I think this, you know, as I have said in a blog post about this very topic, nobody wants to learn English verbs for exactly this reason. Irregularity is bad in language. So flexibility, this gets right down to simply, can it do the things you need it to do in order for it to meet your business needs, your needs for your modeling approach or whatever. If it doesn't do, you know, XYZ kind of thing, then you're really hitting a break point. And Altair has a big problem in this area, which I'll talk about a little later. Then I care about aesthetics. I think that visual attractiveness is really cool, and I think it's really helpful for actually communicating what you want to communicate about the information. You're making this visualization to communicate to either someone else or to yourself, and you want to get the understanding of the underlying data through. And if things look more appealing visually, you're more likely to actually have a successful visualization in that respect. I think we get to a point where either people are committed to attractive, you know, output and will scrutinize and write 20 lines of code to get, you know, this particular color in this particular spot that you want. I don't think people have time for that. But I also don't think we want the equivalent of, you know, plain black font on plain white slides for visuals, because I think that's ineffective. So we need a middle ground. We need something that's attractive, easy to look at, easy to understand, but also doesn't take us all day to build. Interactivity is a different thing. Interactivity has technical limitations under the hood, right? If you want to be able to make a plot that you can, you know, spin around, or you can zoom in and out, or you can select certain subsections, that's very exciting, but not necessarily really, you know, required for most visualizations to be effective. But some of these libraries can do that, and it's neat. And so I'm going to show you a couple of examples of how that can be done as well in the ones that we have here. Okay. So what are my tests? Like I said, 5 plots, a sixth is sort of the bonus, the 3D scatter plot, which is only doable in 2 of these libraries. So first, histogram, basics. Take a category, you know, take a series, bucket it into categories that are numeric, put it on the plot. Scatter plot and faceted scatter plot. So we're doing a plain scatter plot, but then also a grouped scatter plot, right? So faceted, giving a categorical grouping of at least two categories. Grouped bar tends to be particularly gnarly for some visualization libraries, in not so much in terms of generating it, but in terms of labeling the dang thing. and then a time series line. So take time series data, plot it in a line, and then group the lines so that the lines represent different series along the same time series. The 3D scatter plot is kind of an extra bit, which I'll show you a little bit in a moment. The data set I'm using are musical tracks from Spotify. So I picked out the data set. I think it came from Kaggle in its original form from my set. And so it's got a whole bunch of characteristics of each song. So speed, danceability, explicitness, all kinds of things. And so that's the data that I'm using to do these tests. And again, I'm trying as much as possible to replicate the same visual experience, library to library to library, with the same data and the same underlying plot type. So they won't all be the same, which is fine. It's totally natural. But I'm trying as much as possible to sort of give them all an even playing field. So let's start with Matplotlib. Matplotlib, you can actually start with pretty simple code and get a pretty decent plot out the gate. However, the minute you want to visually design anything, resize the plot, add some extra, do the facets, the bells and whistles, you really get into deep complications right away. It does an okay job handling multiple series overlays. The danceability in the bottom middle is one example of that. Grouped bar labeling, nightmare zone. I would not do that in Matplotlib, but by and large, there's just a few things it can do okay. I think the default visual appearance that you're seeing on screen right now, this is pretty ugly to me. If you don't think this is ugly, wait till you see how gorgeous some of these other plots will be. You might be used to this, and so you might be sort of in that mindset that this is what plots have to look like in Python, and you're wrong. They can look so much better. And so let's take a look at the code sample. So I've got some code here. Hop through into Matplotlib. So this is an example of how you do the histogram in Matplotlib. You'll notice this first line of code, honestly, for a new user who's never been in Matplotlib before, even a user who's done data visualization and other tools, it looks like gibberish. It really does. Because Matplotlib is coming at this with an idea that the figure and the axes are different objects at the beginning. And cognitively, a new user is coming at this like, wait a minute, how can you have a figure with no axes? They're like, what is that? How is this supposed to work? And then you start adding methods onto the axes, and you've lost the new user. Everyone has to Google this first syntax because everyone forgets exactly how it's supposed to. What is that again? And like subplots and what is it? I don't think you should have to Google every single time you want to do something in a visualization library. And unfortunately, with Matplotlib, you really do. So let's go back to us here. So let's give it a report card, right? I do not think the learning curve is easy, as evidenced by the fact that everyone has to Google for every single time you want to start a new Matplotlib's plot. And like, if I asked you to start from scratch and just write one, you would have to struggle. Even users who are pretty experienced. The grammar consistency is sort of okay. I mean, it is based on a relatively sort of uniform approach, but it's coming out of this Matplotlib syntax that I just don't think is very intuitive to folks. The flexibility, you can do a lot with it. There are a lot of things you can definitely do. Not going to argue with that. However, things like labeling that group bar plot just made me tear my hair out. And as you'll see, I've spent a lot of time with a lot of visualization tools here, and it just shouldn't have to be that hard. I think the plot output is grainy. I think that the default color schemes are dull, and I think just generally, I'm not impressed with the visual quality of the output. And there's no interactivity available, which is just a technical aspect of the underlying characteristics, so that, I'm not going to hold it against them. So Matplotlib, by and large, it's where a lot of us start and where a lot of Python users start for data visualization, but you can do so much better. So let's talk about Seaborn. Like I said, layer on top of Matplotlib. It does not have its own 3D plotting interface at all. You just go to Matplotlib for all of that if you're working in Seaborn. I do think the attractiveness is a little bit better. I think it's still not resolution-wise very sharp, and so for interaction like this, where you're looking at it on, say, a slide, it's a little grainy, a little sort of fuzzy around the edges, and that's not really something you can do much The API is a little unclear because it's layering on top of Matplotlib, but it's sort of adding different approaches to certain things. So some stuff you do with a particular like command or function, and other things will, for no clear reason, have a different syntax or a different API. It's not a great look. Multiple series overlays, so like danceability, as you can see here, actually require melting your data into a long form. You can't just layer over the top, which is annoying. It's not a huge deal, but it's an annoying thing to have to do. So you end up doing a lot more data manipulation before you pass the data into the visualization library. Well, let's take a look at some Seaborn. So here's the code. You'll notice we're starting again with the subplots call that we did in Matplotlib. So it's really telling you that we're on the same sort of foundation, but then the code does get better, right? It's making a little bit more sense. We're starting with our white grid background, and I'm trying then to add the histogram plot. The feature that I want to plot the histogram for is not too bad, and then I set the width of my bins and we're off to the races. Adding the title and the label here is not too bad, but once again, that set title thing doesn't work for every kind of plot in Seaborn, so you need to keep that in mind as well. Okay. So, would I say the learning curve is easy? No, I think it's, if anything, more difficult because you're learning kind of two different approaches between Seaborn and Matplotlib, and you really have to learn them both. The grammar is less consistent, again, because of, I think, that same sort of thing. And if you're trying to build an added layer of additional feature functionality on top of an existing library, this is just a thing that you're going to run into, I suspect. So I don't want it to seem like I'm, being overly critical because of that, but it's a problem when you're trying to learn the thing. The flexibility is better than what you see in Matplotlib. It adds some features, adds functionalities that people want, but it's still not exceptional. It's also more attractive output, for sure. I think that the defaults, hey, they've changed a few things that make for a more attractive output, but there's still some underlying sort of limitations that you just can't get around without starting from a whole new backend, which we'll see in a little bit. It's also not interactive, but as I said, not a big deal. So let's look at bokeh. Okay, this is a totally different universe of data visualization tools. This is a JavaScript backend, so it has gorgeous plots. Plots look just beautiful, in my opinion. However, this does also mean that there can be some slowness in the loading process. So when you're actually loading one of these plots into, say, Jupyter Notebook or something like that, sometimes it just won't load at all. You got to refresh. It can be a little bit of a pain. However, if you want a really sharp plot to, say, screenshot into a presentation, like I have done here, it's amazing. It looks really, really good, in my opinion. The grammar makes pretty good sense. We'll look at it in just a second. You kind of you create a figure object and start adding series that are called glyphs in this case. The consistency is pretty good. Figure aesthetics, once you learn kind of how to set aesthetics, you'll know after you go along. And so you can learn this and improvise on it. There's one weird thing though in bokeh, and you'll see this in just a moment. The histogram is not a natively supported plot type. So oddly enough, when I randomly chose the histogram to be sort of the first thing that I would try for each library, bokeh just doesn't do that. You have to create a different data series altogether from NumPy histogram in order to generate one. So let's take a look at that and I'll show you what I mean. So there we go. So this is what you do when you want to create a histogram with bokeh. So you create a histogram with NumPy and create the bins and all of that with the data, the series that you're looking for. And then you have to play that into the bokeh syntax using what's called quad, which is literally creating little boxes on the page. So this is kind of slapping it together with, spit and duct tape. It's a little weird. Aside from this, bokeh does seem to have almost all of the data, visualization features that I would want to see. You've got your zooms and your histogram can be interacted with in nice ways, which is pretty cool. So you can do all kinds of stuff that you want to do to interact with it. So I think that's really neat, and I think that's a big advantage. If you're interested in doing that kind of thing, you can look more closely at your data and stuff. But bokeh is not the only plotting tool that can do that. So we'll talk about that a little bit more in a moment. So report card. I think it's actually pretty easy to learn this. I had no experience with bokeh before starting working on this project to really learn the tools that are out there, which is kind of embarrassing because it's been around for such a long time, but it actually works pretty well. The consistency of the grammar, I only have to dock it a little bit because of the weirdness with the histogram, but really, by and large, it's pretty good. It's very flexible. You want to change the colors, you want to change the labels, you want to move the axes, you want to do whatever you want to do. It's got pretty much the functionality there for you to do that. I really think the output is pretty, and I think that the the customizability of the attractiveness is really a nice thing to highlight. And then, yeah, it's interactive. As you saw, you can zoom in, you can move around, you can show the details of plots. This is only useful for interactive, in presentation formats. If you're putting something out in, say, HTML, you're putting out a website, you're doing something with, with Jupyter notebooks or something like that, then it's a nice thing to have available. It could be really cool. But remember, it may load slow depending on the size of the data you're working with. Okay, so let's talk about Altair. Altair is a different game from bokeh, but it's also based on a JavaScript backend. Before I really get very far with Altair, I mean, I do like it, but there's a big problem. It really can't handle large data volumes. And I don't mean like in bokeh where it gets a little bit slow with large data volumes. I mean, it really can't handle it. If you use a data set of more than 5,000 rows, which is really not that much data, it will create an error that says this is too much data, we can't. You can override this, but you do so at your own peril, because when you override that error, then it will try to run on the larger volume of data, but it will be very slow and very difficult to work with. So I can see why they created that error, but I don't think it's a good user experience either way. So when you can group data in advance to, pre-group it and then do something with it, like this, grouped bar plots or something like that, then it's not so bad. But it's if you really want to do something with a lot of data points, you're going to have to downsample, was basically what I came up with. And so the plots that I'm showing you here in the middle of this slide are downsampled because I just didn't have all day to try and make this thing behave with larger amounts of data. Now I've said the nasty stuff about Altair, and I do want to say that this is a really fun library to use. The syntax is really easy. It's very intuitive to work with. I like the way that the plots look. They've got that lovely crisp JavaScript stuff coming out that I just am in love with. The encoding scheme is a really unique and lovely feature of this that allows you to indicate to the plotting engine what kind of data each feature is without having to go into like changing the types of your columns and this and that, and I'll show you in a moment. And the stuff like, little features like the legends default mappings look really nice. There's just a lot of care and attention put into the details and the appeal of a lot of these plots. It's just that 5,000 data row limit thing is a little baffling. Okay, so let's look at some Altair code. So here's an example of the histogram in Altair. It is a little bit interactive. You kind of can do a little bit of stuff with it, not much really, but it's got the ability to move it into Vega, the underlying library, and do some things. So first I'm setting my data sample as you can see, 5,000 rows, because I can't give it the whole data set that I would want to give it. Now I create the visual object, the chart. I start saying it's going to be bar plot. I give it the encodings for X and Y, and then add some labels and some, size stuff, and that's it. It's really pretty, right? It comes out of the box looking really nice. You'll notice I've got commas in my count of records. I didn't have to tell it that. It's got some really lovely thoughtfulness involved. But once again, we've got the problem of figuring out how to get it into slightly larger data sets. Okay, report card. So yes, easy learning curve. Very easy to learn, very easy to get started. I think that that's a huge advantage. The grammar is very consistent, smooth. Once you've learned sort of steps to it, you can really interact with it. the limitation of the data is just, it makes me sad because I would really like to recommend it for more things, but without that, I just can't. I think the output is gorgeous. I think it looks great. I think it's very attractive to the eye, and it really not interactive for all intents and purposes when you're working in Python. Plotnine. A lot of people who come to Python from art and visualization, you know, sort of terms, they're wanting to do their machine learning in Python. They hear that Python has so many amazing things, all of the scikit-learn opportunities. There's so much stuff with NLP that you can do, and they're like, but how do I make a plot that's any good? This is the sort of training wheels, I suppose, for people coming to coming from R to Python. It's a port of ggplot2's API almost exactly into Python. And this is an amazing feat. I want to like tip my hat to the developer of this library because those are very different languages and very different syntaxes, and they managed to create a really seamless, more or less, version of ggplot2 in Python syntax. And I'll show you how it looks in a moment. But for our users who come from ggplot2, you will not really need to look up much. This thing will, this library does what you need. It will understand the syntax that you're used to, and it has pretty much the robustness of the features that you want. I will say, I don't like the visual sort of aesthetics very much because it's built on top of a Matplotlib layer. So this is sort of a different API into Matplotlib. So the appeal of the plots, unfortunately, has the same problems that you might have run into with Matplotlib. But at least you don't have to use Matplotlib syntax. So there's something. Let's look at some plotnine code. Okay. So here's an example of a histogram with plotnine. So I'm setting some DPI and figure size stuff to try and, you know, sort of work on the aesthetic appeal. It's not awesome, but it's something that I was messing around with just for my own edification. But otherwise, you look at this, and this is ggplot code. This is data mapping to the aesthetics, theme, histogram, labs, done, right? And it should look very familiar to any R developer. You'll notice that you have to add these backslashes on the ends of the lines to create new lines so that it continues without breaking on each side. But aside from that, you're really not doing much of anything else. It's not interactive. You're not going to get any sort of zooming or any kind of ability in that regard here, but that's, you know, not everybody can have that, right? But yeah, as you can see, the code really does look just the way you might expect. Oops, wrong one. So, port card. Yes, the learning curve is super easy, especially if you know R. If you come from ggplot, you will find this feels like a comfy old pair of shoes. You're not going to have any trouble with that. The grammar, I think, is consistent. I'm biased. I like ggplot too. I think it's great, and I think that it's been developed and refined over quite a period of time to be a good library, and so I think that that's worth maintaining and worth porting over. It does all the kinds of plots that you would expect. It's got the customizations, the color stuff, the theme stuff, things that are already expected out of ggplot2. So yeah, I think flexibility, it gets full marks. The output isn't great. You can do a lot of fiddling and trying to get the aesthetics of the output the way you want. I'm not going to say that they get there necessarily. You know, it's a trade-off. And it's not interactive, but you know, lots of things aren't interactive. So our final contender is Plotly. Plotly is a totally different kind of beast here. It is based on plotly.js, ported into Python, and it requires some handholding to make really attractive output, but for the like interactivity and like zoom and stuff like that, oh, it's great. It really does give you a remarkable interactivity with minimal user effort. There are two kinds of Plotly, however, and this is hard to explain in some ways, but there's Plotly Express, which is sort of meant to be the beginner Plotly. So this is the don't have to learn a whole bunch of syntax, don't have to get real into the weeds Plotly. And then there's Plotly Graph Objects, which is full featured Plotly. You might expect that you could learn a little bit of Plotly Express and then sort of, level up into graph objects. It doesn't quite work that way though, because Plotly Express syntax doesn't have a ton in common with Plotly Graph Objects. So you would say, okay, oh, I can stick with Plotly Express and not get into graph objects. But I find so quickly when you start working in Plotly and you want to, break things into a couple of series, or you want to add this, or, little features that you think would be not that complicated, you got to go into graph objects. And so Plotly Express, I don't think has a particular niche. I don't think that there's a real need for that because there's so many good libraries that I've already described that are really easy for the beginner user to learn. And then graph objects is really what you need in order to get the interactivity, the 3D stuff, some of the really cool features. Why would you ever start with graph objects or with Plotly Express? I'm not sure. But let's look at some Plotly syntax and you can see for yourselves. So what I'm going to show you here is just Plotly Express for now. So this is creating a histogram, Plotly Express. You get your data set, you map your X, you tell it how many bins you want, few little aesthetic features, layouts, shape and size, and you're good. And this is actually really nice. And you'll see it's very interactive. You've got your labels. I didn't have to ask for any of that. You can do selecting just like I did with the bokeh one, and you can get in there and zoom in and look around and all kinds of neat stuff. It's very cool. It has a lot to offer, but at the same time, you could do this with a lot of different libraries, and then if you wanted to move up to more complicated stuff, this syntax is no longer going to apply for you. So let's get back to it. So report card for Plotly. Not really that easy to learn because you kind of learn something and then you're starting all over as soon as you want something a little more full featured. The consistency of the grammar, it gets lost because you start from one place and then have to change lanes. Flexibility, they got it going on. Plots can do anything, and they've got so many different features and so many different functionalities from Plotly that I gotta really appreciate that. I think the plots look really ugly coming out, to be honest. There's a few that look okay, but some of them just like the basic Plotly Express plots, I'm not a fan of the look. Maybe you are, maybe you think that looks great, and yeah, that's more power to you. But they really win 3D, interactive, zoom in and out, turning things around and all that kind of stuff. And so I think that's pretty cool. So let's do a little bit of talking through exactly what we have learned, okay? Sensible grammar, easy to learn. I think plotnine and Altair really take the cake here. I think those are the easiest ones to start with and learn. That doesn't mean they're necessarily the easiest ones to continue using in a full-featured way. Interactivity, Plotly and bokeh are the only games in town, and Plotly does more as far as interactivity. So if that's something to consider based on your individual project and needs. Great images, really attractive plots, Altair and bokeh win. And for flexibility, full featuredness, I would say plotnine and bokeh are also pretty much the winners here. If you want a single library that you won't have to change up a lot, you won't have to fuss with, I would say go with bokeh, honestly. It's not the winner in every category. It's got some disadvantages, it's got some downsides, but it's got sort of the common denominator of I think the plot library that you'll find most easy to continue to use without having to change up a lot of stuff. So now I want to talk a little bit about my best of winners. So I looked at all of these different approaches to visualization and approaches to plotting, and I found some, libraries that really stood out as pretty excellent for their kind of plot. So let's talk a little bit about what we're doing with that. So histogram, I think plotnine actually wins this category. And remember, I'm going for a couple of different criteria, right? I've got the ease of use, easy to do, to write the code, quick to develop, also attractiveness and other things. It's not the most attractive. I think it looks pretty good, but writing this is so easy and so intuitive and streamlined that I think that plotnine really takes the cake when it comes to just this plain old histogram. But what about scatterplot? I think bokeh is really the one that wins here. So this is the basic syntax for a bokeh plot, as we've talked about a little bit earlier. We've got our figure, title, axes, height and width. This is sort of aesthetic stuff that you set on the figure. And then you add the scatter. So this is the scatter plot. We've got our X, Y markers, colors, and so on. It's really easy to write, and you get a ton of those, zoom in and out and mess around with things features that I showed earlier. And that's kind of an advantage that you just don't get with a lot of these other options. I think it looks really nice. I think the attractiveness is worth the extra little bits. And so I would recommend bokeh for the regular scatter plot. Oh. And now I've accidentally frozen. So what you're seeing now is an evidence of bokehs struggling with larger data sizes. It starts to slow down and it starts to get to be a little bit of a problem for bokeh when you're trying to get a little bit more data running into the thing. So I'm gonna quickly tell bokeh to behave itself. Give it a second here, it should come along. And then I'll quickly go through the other of my winners. The particular one about timelines here, I'll show you. This is a multi-series timeline, and bokeh does a really nice job with this as well, and so I think it's worth showing. Yeah, I'll go back to the group bar in just a sec. So once again, we've got our figure, we've got adding different lines, and you just add by the different series you want to add, and everything works really smoothly. It keeps the time series the way you want it, doesn't have any trouble with that. And so I think as far as a time series plotting line, bokeh does a nice job. But let's look at this group bar that I missed because of bokeh's slowing me down. Altair, because you can group ahead of time, this is the one where I think I can recommend Altair without reservations. It's beautiful, it looks so nice coming out, and I'm able to use these custom data typing syntax that is just a feature of Altair to tell it that, okay, group is here, and so danceability quantitative, group is a name, I believe, and then, or wait, color is binary for group. And so you're able to use these sort of shorthand syntax to tell it what kind of type you're looking for. And that's just a really nice little feature that not everybody gives you. So finally, the 3D scatterplot, the piece de resistance. I think this looks so neat and it's worth doing, but you'll see how complicated graph object syntax actually is. What we're looking at here is we're setting the X, Y, and Z axis, right? Because it's a 3D scatter plot. And so I'm downsampling my data. Because it looks better on a plot when you're doing 3D to not have too many points. This isn't required for Plotly. I'm giving it all of the features that I want to use, X, Y, Z, and the color. And then I'm creating the graph object figure, which has data. And we're already starting to get into like nested brackets and parens and things, and it's starting to get a little bit hard to read already. If I hadn't set X, Y, Z in color out here, it would be nightmare to read. And so that's our starting point. And then we add all of the aesthetics to the layout, including the Z-axis element, which is a specific thing that I loaded earlier. And now we've got this. I think this is worth having, because check out what you can do with just this Plotly code. I can look at any single individual point. It's color coded according to the color scheme I set. I can spin it in every direction. And like if you were looking for, I'd use this for PCA a lot. So for clustering, to try and figure out if I'm actually getting at the base, the features that I'm looking for and that kind of thing, to see the shape of my whole feature space. It's great. I really like it. So I just wanted to make sure that you all had a chance to see that. And that brings me, to the conclusion. I would love to answer any questions if you have any. We've got a couple of minutes left. 5 minutes looks like. I still like R for data visualization, and I'm not going to be ashamed of that. I think that R still really has the most robust, full-featured, and community-supported data visualization ecosystem. But when you're working everything else in Python and you don't want to transfer your code back and forth, you do have options. There are libraries out here. You have lots of wonderful choices, but pick the one that's going to work for your specific needs. And then I think you should be in good shape. So with that, I will take any questions that folks have. Let me see if I can turn on camera so you can actually see me instead of slides. Do we have any questions?